In computer science, the Boolean data type is a data type, having two values, intended to represent the truth values of logic and Boolean algebra. It is named after George Boole, who first defined an algebraic system of logic in the mid-19th century. The Boolean data type is primarily associated with conditional statements, which allow different actions and change control flow depending on whether a program a specified Boolean condition evaluates to true or false. It is a special case of a more general logical data type. Logic does not always have to be Boolean. Generalities. In programming languages that have a built-in Boolean data type, such as Pascal and Java, the comparison operators such as greater than and are usually defined to return a Boolean value. Conditional and iterative commands may be defined to test Boolean-valued expressions. Languages without an explicit Boolean data type, like C90 and Lisp, may still represent truth values by some other data type. Common Lisp uses an empty list for false, and any other value for true. C uses an integer type, where relational expressions like I greater than j and logical expressions connected by an and are defined to have value 1 if true and 0 if false, whereas the test parts of if, while, for, etc. treat any non-zero value as true. Indeed, a Boolean variable may be regarded as a numerical variable with a single binary digit, which can store only two values. It is worth noting that the implementation of Booleans in computers are most likely represented as a full word, rather than a bit. This is usually due to the ways computers transfer blocks of information. Most programming languages, even those that do not have an explicit Boolean type, have support for Boolean algebraic operations such as conjunction, disjunction, equivalence, exclusive or non-equivalence, and negation. In some languages, like Ruby, Smalltalk, and Alice, the true and false values belong to separate classes, e.g., true and false, resp, so there is no single Boolean type in SQL, which uses a three-valued logic for explicit comparisons because of its special treatment of nulls. The Boolean data type is also defined to include more than two truth values, so that SQL Booleans can store all logical values resulting from the evaluation of predicates in SQL. A column of Boolean type can also be restricted to just true and false though. Algolan, the built-in Boolean type, one of the earliest programming languages to provide an explicit Boolean data type, was Algol 60 with values true and false and logical operators, denoted by symbols. And, due to input device and character set limitations on many computers of the time, however, most compilers used alternative representations for many of the operators, such as an OR, and this approach with Boolean as a built-in data type was adopted by many later programming languages, such as Simula 67, Algol 68, Pascal, Ada, Java, and C#, among others. Fortran. The first version of Fortran and its successor Fortran 2 did not have logical values or operations. Even the conditional if statement took an arithmetic expression and branched to one of three locations according to its sign. See arithmetic if. Fortran IV, however, followed the Algol 60 example by providing a Boolean data type, truth literals, Boolean-valued numeric comparison operators, and logical operators. In format statements, a specific control character was provided for the parsing or formatting of logical values. Lisp and Scheme. The Lisp language never had a built-in Boolean data type. Instead, conditional constructs like cond assume that the logical value false is represented by the empty list was retained in most Lisp dialects, and similar models were adopted by many scripting languages. even ones that do have a distinct Boolean type or Boolean values, although which values are interpreted as false, and which are true, vary from language to language. In Scheme, for example, the false value is an atom distinct from the empty list, so the latter is interpreted as true. Pascal, Ada, and Haskell. The Pascal language introduced the concept of programmer-defined enumerated types. A built-in Boolean data type was then provided as a predefined enumerated type with values false and true. By definition, all comparisons, logical operations, and conditional statements applied to and or yielded Boolean values. Otherwise, the Boolean type had all the facilities which were available for enumerated types in general, such as ordering and users indices. On the other hand, the conversion between Booleans and integers still required explicit tests or function calls, as in algebra.It. This approach was adopted by most later languages which had enumerated types, such as modular, Ada and Haskell. C, C++, Objective-C, awk. The initial implementations of the C language provided no Boolean type, and to this day Boolean values are commonly represented by integers in C programs. The comparison operators are defined to return assigned integer results, either 0 or 1. Logical operators and condition testing statements assume that 0 is false and all other values are true. After enumerated types were added to the ANSI version of C, many C programmers got used to defining their own Boolean types as such, for readability reasons. However, enumerated types are equivalent to integers according to the language standards, so the effective identity between Booleans and integers is still valid for C programs. Standard C provides a Boolean type, called _bool. By including the header std bool, H1 can use the more intuitive name bool in the constants true and false. The language guarantees that any two true values will compare equal. Boolean values still behave as integers, can be stored in integer variables, and used anywhere integers would be valid, including in indexing, arithmetic, parsing, and formatting. This approach has been retained in all later versions of C. C++ has a separate Boolean data type bool, but with automatic conversions from scalar and pointer values that are very similar to those of C. This approach was adopted also by many later languages, especially by some scripting ones such as awk. Objective-C also has a separate Boolean data type bool, with possible values being yes or no, equivalents of true and false respectively. In addition, in Objective-C compilers that support C99, the C's _bool type can be used. Perl. In Perl, there is no Boolean data type. Instead, any value can behave as Boolean in Boolean context. The number 0, the strings 0, and the empty list, the null value, the empty string, and empty containers are considered Boolean false. All other values are considered Boolean true by default. Classes can define how their instances are treated in a Boolean context through the special method __non0 _or _bool__. For containers, __len _ is used if the explicit Boolean conversion method is not defined. In Ruby, on the other hand, only nil and a special false object are false. Everything else is true. In JavaScript, the empty string, null, undefined, nan, +0, -0 and false are sometimes called false, and the complement, true the, to distinguish between strictly type-checked and coerced Booleans. Languages such as PHP also use this approach. SQL. The SQL 1999 standard introduced a Boolean data type as an optional feature. When restricted by a not-null constraint, a SQL Boolean behaves like Booleans in other languages. In SQL, however, the Boolean type is nullable by default like all other SQL data types, meaning it can have the special null value as well. Although the SQL standard defines three literals for the Boolean type: true, false and unknown. It also says that the null, Boolean and unknown may be used interchangeably to mean exactly the same thing. This has caused some controversy because the identification subject's unknown to the equality comparison rules for null. More precisely, unknown equals unknown is not true but unknown, null. As of 2012, few major SQL systems implement the TO31 feature. PostgreSQL is a notable exception. Although it does not implement the unknown literal, null can be used instead.